Good morning. I am Dr. M. Shaktivel, Professor, Artificial Intelligence and Data Science Department, Sri Shanmuga College of Engineering and Technology, Sangagiri, Salem. In this video, I am going to explore two important measures that describe the shape of a distribution, skewness and kurtosis. These are important in statistics as well as data science and any analytical field where we want to understand how data behaves beyond mean and variance. Whenever we work with the data, we don't just care about its central value or its spread. We also care about the shape of the distribution, how the values are arranged. The two key characteristics of shapes are, the first one is skewness and the second one is kurtosis. Skewness tells us whether the data leans left or right. Kurtosis tells how peaked or how heavily tailed the distribution is. Understanding the shape helps us to choose the right statistical tool, detect abnormalities, and make accurate predictions. Skewness measure the asymmetry of a distribution. In a perfectly symmetric distribution, like a normal distribution, the left and right sides look the same. But most real world data, it is not perfectly symmetric. So in skewness, we have some questions. Does the distribution stretch out more on the left, or does it stretch out more on the right, or is it roughly balanced? Generally, normal distribution has a skew of 0. Before we discuss skewness, let's recap the three measures of central tendency: mean, median, and mode. The first one, the mean, is the arithmetic average. It is sensitive to extreme values. If you have 1 billionaire in our organization, then the mean income will be very high, even though other employees are getting the salaries in 1000. The second one, median. Median is the middle value when data is ordered. It is robust to outliers. The median income in that same organization would be much more representative of typical earnings. The third one, mode. Mode is the most frequently occurring value in salary data. The mode might be the entry level salary that many recent employees earn. In a perfectly symmetric distribution, all three are equal. Mean equals median and median equals to mode. But when the distribution is skewed, these three measures diverge. And the pattern of how the diverge tells us the direction and magnitude of the skewness. Now let's dive into skewness. Skewness is a measure of the symmetry of a probability distribution. It quantifies how much a distribution deviates from perfect symmetry. There are two types of asymmetric skewness. The first one is positive skewness, also called as right skewness. The second one is negative skewness, also called left skewness. The symmetric, we have only one. The symmetric skewness, or we can call it as zero skewness. The direction of skewness refers to where the tail extends, not where the bulk of data is located. This is common point of confusion. So remember, skewness is named after the tail direction. Let's start with positive skewness, also known as right skewed distributions. So if you see the visual, the tail extends towards the right. So that's why we are calling it as positive skewness. It's in the positive direction. the bulk of data is concentrated on the left. Then automatically the peak is shifted towards the lower values. So how can we relate this mean, median and mode in positive skewed or right skewed? Mode is less than median and median is less than mean. This mean is sensitive to extreme values. A few large values on the right pull the mean upward, while the median stays closer to where most data points are. Some real world examples. So many real world examples, just I'm giving few. Income distribution, house prices, exam scores on EC test, website visit duration. Let me see only one real world example. Income distribution. So most people earn moderate incomes, but a small percentage earn extremely high incomes. The super rich create the long right tail. This is why median income is often reported instead of mean income. It's more representative. Now let's look at negative skewness or left skewed distributions. If you see the diagram, the tail extends towards the left, that's the negative direction. The bulk of data is concentrated on the right. The peak is shifted towards the higher values. So the relationship between mean, median and mode is mean is less than median and median is less than mode. If you notice the relationship, it is reversed from positive skewness. The mean is pulled down by extreme low values. Some real world examples. The first one is the age at death in developed countries. The next one is exam score on different difficult tests. The third one is product ratings, and next one is age at retirement. The next one is survival time of high quality products. Let me expand this product ratings. Many products usually receive 4 or 5 star ratings from satisfied customer, but dissatisfied customer may give 1 or 2 star. That create a left tail. The negative skewness indicates that most values are high, but you have occasional low values. This often occurs with the ceiling effects when there is an upper bound that most values approach. The negatively skewed distributions are less common than positively skewed ones in natural phenomena, but they are important in quality control and satisfaction studies. Now let me understand what skewness means conceptually. Let's look at how to measure it quantitatively. There are several formulas for calculating skewness. Let me show you that the most commonly used ones. The first one is Pearson first coefficient skewness, which is called mode based. So skewness, how we are calculating mean minus mode divided by standard deviation. This is simple and intuitive. If the mean is greater than the mode, skewness is positive. If the mean is less than the mode, skewness is negative. What is the limitation of this equation is the mode can be unstable, especially in small samples or continuous data. Next equation, Pearson's second coefficient, which is median based. So here we are calculating skewness is equal to 3 into mean divided by median whole divided by standard deviation. This is more robust because the median is more stable than the mode. The factor 3 is an empirical adjustment based on the relationship between mean and median is skewed distributions. The skewness is between -5 and 0.5. The data are nearly symmetrical. If the skewness is between -1 and -0.5, negative skewed, or between 0.5 and +1, then it is positive skewed. If the skewness is lower than -1, negative skewed, or greater than 1, it is positive skewed.